Welcome back to another explainer. Today, we're diving into something you interact with literally every single hour, yet the science happening right there in the palm of your hand is completely invisible to you. We're unpacking the hidden physics of cell phone antennas. So right off the bat, are you holding your phone wrong? Now, I know exactly what you're thinking. It's just a rectangle. I grab it. What's the big deal, right? But as we're about to see from some really incredible research, your everyday, totally natural smartphone grip might secretly be destroying your device's signal. Let's look at the actual data and figure out what is going on here. Okay, let's dive into this. To really understand the problem, we first have to figure out how a phone performs when we humans aren't messing it up. Here we've got a baseline test using an HTC phone. It's transmitting at a maximum power of 33 dBm, which is basically 2 watts. The researchers set this device up in what they call a free space configuration. All that means is it's just sitting there, completely unobstructed by human hands. And under these perfect conditions, the antenna efficiency is a very solid 78.35%. This is the phone doing exactly what it was engineered to do, pushing out a strong, clear signal. Now, what's really interesting about this slide is the testing environment itself. To get scientifically accurate data on how our hands mess with that 78% baseline, you need total isolation. Notice those crazy blue, spiky, wave-absorbing walls? That is an anechoic chamber. It's literally designed to swallow electromagnetic waves whole. By putting a human subject inside this room, researchers can isolate the exact physical impact of a hand or head on the antenna, with zero outside interference. All right, here is where the story gets pretty dramatic. We start with our baseline at 78.35%, but look what happens when the person just brings their hand near the device, the hand not covered configuration. Boom! The efficiency instantly drops to 34.91%. Just the sheer proximity of human tissue absorbs more than half the signal. And it gets worse. When the hand actually covers the bottom area, efficiency plummets to 3.16%. And then we hit the final row. When the phone is held the normal way, up against your ear for a call, the antenna efficiency just entirely collapses. Yes, you're reading that correctly, 0.29%. I really want to pause on this for a second because it's kind of mind-blowing. When you hold your phone the normal way, just pressing it against your head to take a call, you are tanking your device's antenna efficiency to a staggering 0.29%. You are losing over 99% of your phone's transmission power simply by holding it the way it intuitively feels like it should be held. So the crucial point is, why? Why does this massive drop happen? Well, look at the physical dynamics here. When we lift a phone to our ear, our natural tendency is to wrap our fingers right around the bottom of the device just to support the weight, right? Well, unfortunately for us, human hands are essentially kryptonite to electromagnetic waves. And that bottom section, that is exactly where the primary cellular antenna lives. By wrapping your hand around the base, you're basically slapping a physical brick wall right over the antenna. So we clearly have a massive engineering problem on our hands. But thankfully, we also have a solution. Let's look at the GWT Grip Guide solution, engineering a better hold. And this brilliantly illustrates the fix. Back in 2017, inventors Arthur J. Nghiem and Dr. David Nghiem designed what you see over on the right, the GWT Grip Guide. They looked at that dismal 0.29% efficiency and realized, hey, if you can't change human nature, you have to physically guide it. Compared to the terrible normal grip on the left, check out how the scientifically corrected GWT grip shifts the hand away from the bottom of the phone. It actively changes your physical geometry, pulling that wave-absorbing human tissue up and away from the critical transmission zone. And the results of this simple shift are absolutely massive. By using the GWT holding method, efficiency recovers from that abysmal 0.29% all the way up to 16.6%. Now, actually, you might be thinking, wait, 16% is way lower than the 78% baseline. And yeah, that's true. But in the real world of everyday cellular transmission, jumping from practically 0 to 16% is an incredible game changer. It is literally the difference between a dropped call and a perfectly clear conversation. But here's the catch. How do you get someone to actually hold the phone this way without them constantly overthinking it? Well, the inventors solved this with an ingenious hardware trick, the push-in/pop-out protrusion design. Notice how the case incorporates these physical little bumpers on the sides? Those aren't just for looks. They physically block your hand from sliding down over the antenna. It unconsciously guides your fingers to rest in the correct higher position. It's a textbook example of design dictating function.
You don't even have to learn a new habit. The phone just makes you hold it right.
So what does this all mean for you and me? The research highlights two major everyday benefits. First, by not smothering the antenna, you drastically improve system performance. We're talking better battery life, faster data, fewer dropped connections, the whole shebang. But second, and honestly perhaps more importantly, keeping your hand away from the antenna significantly reduces personal radiation exposure. Because the antenna isn't desperately struggling to push a signal through your hand, the device operates way more efficiently, meaning way less energy is absorbed by your body.
It is just fascinating how a slight adjustment of your fingers can completely rewrite the physics of your device. So it kind of leaves you wondering, the next time your phone rings, will you ever look at holding it the same way again? Thanks so much for joining me today to unpack this explainer. Keep questioning the world around you, and I'll catch you in the next one.